702 and Cape Talk.
The Naked Scientist.
Good morning, Chris, and welcome to the show.
Morning, Eusebius.
I'm always excited because of the enormity that cancer scares present in many of our lives when I see that we have a science story about research on that frontier. And today's science story is about reprogramming cancer cells.
Yep, that's right. So scientists have discovered a way to persuade aggressive spreading cancer cells to turn themselves from being a cancer cell into a harmless fat cell. This is the work of a group of researchers at the University of Basel. This is Gerhard Christofori and his colleagues. The original paper is published in a journal called Cancer Cell, if anyone wants to follow it up. And put simply, what they've done is, initially starting with cells growing in a dish, they started adding various chemicals to those cells to see if they could achieve what they wanted to do, which was turn these very primitive, unspecialised cancer cells, which have all of these aggressive tendencies to grow where they shouldn't, to spread where they shouldn't. And because those cells are unspecialised, they reasoned that they might obey the same signals that guide cells when an embryo is developing from stem cells to make a baby. And those cancer cells that are nasty might have the potential to be turned off in this way by persuading them to turn into a harmless fat cell. And fat cells are a good choice of cell to push them into because those cells are very specialised, they don't grow, they don't divide, and they can't revert themselves back from being a fat cell to anything else. And they found what the factors were, or the signals that you have to send the cells to give them that message, that chemical persuasion. And then their next step was to say, well, are there any drugs which we already use in the clinic, which have already got licenses for other things? And if we add those to an animal with cancer, a breast cancer in this case, could we achieve the same effect? And the answer was they could. And they found a drug which is used to treat diabetes. It's called rosiglitazone. And another drug which is currently used as a kind of anti-cancer drug. It blocks a signalling pathway that tells cancer cells to grow. And when they added those two drugs in combination to animals with a human breast cancer, they could, in 100% of these animals, turn the cancer cells off, and specifically those cells which are most aggressive and most likely to spread around the body. Now, we've got to sound a cautious note because this is just a test in mice at this stage, and obviously it's another step to go into a human clinical trial, but that will be the next step. And because these drugs are already licensed, we already know what their safety and side effect profile is. It's relatively simple, emphasis on the word relative, to translate this into the clinic and do this sort of trial alongside existing gold standard breast cancer treatments to see if we can buy additional responses in people, because this is a serious disease, breast cancer. About 1 in 10 women in her lifetime is going to develop a breast cancer, and if it works for breast cancer, there's no reason why it wouldn't also potentially work in other cancers too. That's what they told me this week.
Fantastic. 11 minutes after 10 o'clock. Lindo, good morning.
Good morning, gentlemen. How are you?
Extremely well, thank you. What's your science question?
That's good. I've got at the risk of sounding a bit blonde. I've heard the rumor that the sky is blue because of the reflection from the ocean. But if that is the case, why are there different shades of blue in the sky? And why is the sky sometimes orange and pink when the ocean remains blue?
Not blonde at all. Lovely blue question.
Lovely question.
Chris?
Yep. Good morning, and thank you for the good wishes. Well, the answer is that the sky isn't blue. It's an illusion that the sky is blue. That's the first important point. And the evidence that you can point out to someone who insists the sky is blue is, well, when it's dark and you see stars which are in the distance, they're shining through the sky to reach you. The light has got to reach your eye, and those stars are white. Now, if they were coming through something blue, then the stars would look blue, and they don't. So it looks blue during the day through an optical illusion effect. So what's the basis of that? Well, the majority of the basis of that is because of the gas in the atmosphere. The light that comes to us from the sun that we can see, so visible light, is white light. And we see white light because that's the combination of all of the colours that we can see arriving together. In other words, if you take all the colours in a rainbow and present them to your eye together, you see white. So that white light hits the Earth's atmosphere, and the blue light, which is in there, is about the same size in terms of its wavelength, how far apart the peaks and troughs are, as the bond between the most common molecules in our atmosphere, nitrogen and oxygen. And because those gas molecule bonds are roughly the same size as blue light, they interact with the blue light coming through the atmosphere and cause it to bounce around a bit like a bullet ricocheting around a room. That has the effect that when you look at the sky, your eye sees the light from the sun coming straight towards you, but it sees blue light, which is bouncing around all over the sky, coming to you from all directions. And your brain solves this conundrum by saying, well, this blue light's arriving from all directions, therefore the sky must be blue. And it's your brain concluding the sky is blue because it sees this blue light coming to you, that the sky looks to you as though it's blue, but it's not.
Fascinating. 13 minutes after 10 o'clock. Pabalo, good morning.
Morning, Zebus. How you doing?
Good. What question have you got for us?
It's a simple one. Does petrol have an expiration date?
Chris?
I didn't catch the first word.
I thought so. It was so pithy that I thought you might not catch it. He was asking about petrol. Does it have an expiration date?
Well, petrol, by definition, is already millions of years old, or at least the crude oil it came from is, because remember that where we get our oil and gas and our hydrocarbons from are dead creatures that sank to the seafloor millions of years ago and then got buried and got squeezed and heated by the energy within the earth and also their own stewing juices, and that temperature and pressure in an extended period of time is what creates crude oil. And when we take that crude oil out of the ground by drilling a hole and then we feed that crude oil into a refinery, you split the crude oil up into all of the different chemical fractions. It's called fractional distillation, and we make certain combinations of those fractions to make petrol. So what's actually in the petrol is already millions and millions and millions of years old. But the blend that goes into the petrol of all the different hydrocarbons that give the petrol its characteristics and other chemicals they add, like the so-called additive pack to give it anti-knocking properties and engine cleaning properties, those things are going to be a unique combination and they're going to be added more recently. If you leave petrol in a sealed environment, i.e. the can is sealed, then it chemically wouldn't change. But obviously you can't do that because it expands and contracts and so on. So you have to have a vented container for your petrol. Even your car's petrol tank has a way of releasing the pressure. And that means that some of the fractions, especially the lighter, more volatile ones, will over time evaporate away from the petrol mix. So although the constituents of the petrol are millions of years old and can't go off, the mixture that's in the petrol will change with time because of evaporation and the loss of the more volatile agents. So old petrol, unless it's been in a genuinely sealed environment with no prospect of escape, which would be unsafe, old petrol is not going to be as good as fresh petrol. And also the blend that's in the fuel mixtures changes seasonally. So the refineries will put into the petrol different mixes, especially in some countries. This is very important where you have big swings in temperature between winter and summer. And that's important because of engine starting, cold running, emissions and so on. So it's better to always have fresh petrol if you can.
Jenny, good morning. Welcome to the show.
Good morning. Some useless information. The Queen Elizabeth is in Cape Town. Myeloma. I've had it for 4 years. They said I'll always have it, but it can be stabilized. Could you give me the history of it, the cause and so forth?
Jenny, thank you for calling in. Myeloma is a kind of cancer of a type of immune cell called a plasma cell. And plasma cells are the cells that make antibodies that then go around in our bloodstream and defend us from infection. And for some reason, in the same way that any kind of malignancy can occur, there's usually a genetic error in the cells that makes a group of cells stop obeying the normal commands that keep them in check and tell them how often to grow, how many of themselves to produce, and where to grow, and they just start to grow and develop and spread autonomously. And what can happen with myeloma is that you end up with these aggregations of these cells, which would normally only occur in certain places in the body, in places like the bones. And so you can end up with these collections of these white blood cells of this type called a plasma cell, in particular the backbone, for example, but in other bones as well. And they can grow quite fast and they can damage the surrounding bone and weaken it. That's one of the consequences. So people might suffer a bone pain or even fractures because of it, and sometimes that's the first time it can be picked up. The other thing it does is because these cells make antibodies, they tend to go into overdrive, and the tumour cells will start to secrete into the bloodstream very large amounts of the unique type of antibody that they, or part of an antibody that they would normally make. And so one other way to diagnose this is often to look for very high levels of a particular group of proteins in the bloodstream. And doctors can use that to keep track on how a person is responding to treatments. Now, the consequences of the action of these this group of growing cells is that it increases the amount of protein that's going around. It can cause problems for kidneys, but it can also release a lot of calcium into the bloodstream. So people often have high levels of calcium. And this can also be one of the reasons why we first discover that they've got the problem. And that calcium can then deposit in various places around the body, including in the kidney, for example. So that's basically what's going on when a person's got the disease. How do we treat it? Well, there are lots of things you can do. You can obviously treat the symptoms and make sure that we keep the bones strong and well and undamaged, and there are drugs to do that. There are also ways of making sure the kidneys stay healthy and blood pressure is healthy, so we can do that. And then there are anti-proliferative drugs. These are drugs that block the turnover of the tumour cells and slow down its growth. We can give those. And then there are even more adventurous things where you can give things like radiotherapy to zap the tumour deposits and stop them growing and developing. So there's a range of different things that people can do about the disease, but it's more a question of making sure we pick it up as early as possible and then giving various preventative treatments to stop the consequences of having the disease rather than trying to get rid of the disease. Although cure isn't totally impossible, because if you caught this early enough and with all the new treatments that are coming along, it's possible to get rid of some of these things in some respects. But on the whole, we aim to manage this as a chronic condition.
I'll take one from Twitter. And Corsi wants to know from you, Chris, why chicken eggs have different colours. We have, he says, brownish eggs in South Africa in terms of the colour of the shell. In some countries seems to be mainly white. What determines these differences in colour?
Well, this is the genetics of the chicken. The chicken adds pigment to its eggs in the same way that any bird adds pigment to its eggs. And by pigment, the bird, when it's making the egg shell, adds to the chemicals that are being deposited around the yolk of the egg, because the egg is formed up inside the bird, and initially a protein sort of scaffolding is laid down, and then as the egg comes down the bird's oviduct, it adds calcium salts to make the shell, and in with those calcium salts are added various pigment colours. Birds do this for a range of reasons. One is to make their eggs hard to spot. So some birds will choose an egg colour which blends in with its surroundings. Other birds add dot patterns to their eggs so that they can count the dots and they know that they're their own eggs. And a good example of why this matters is if you're a reed warbler, for example, being affected by a cuckoo, then you have a better chance of spotting when there's an invader in your nest if you can spot the egg that shouldn't be there, or if you've arrived at the wrong nest and you can see that they're not your eggs. Oh, I've gone the wrong way. So birds do use those dot patterns for that reason, and the patterns depend on the species of bird, and the species of bird depends on its genetics. So it is a genetically predetermined thing what colours, if any, birds add to the shells of their eggs.
Chris, thank you for holding on. What is your question for other Chris?
He's a good man, I can tell. My question is, at night, when you're driving on a straight road and the oncoming car from a distance, the lights from the oncoming car tends to give a shimmer on the road, almost like it's a heat, like heat waves in the day. But it can't be heat waves because it's night and it's cool. So what causes that shimmer on a tar road from the light of an oncoming car at night?
Okay.
Hello, Chris. Well, you say you can't get these shimmering effects at night, but of course you can, because if you look up into the sky and you look at stars, stars appear to twinkle. And the star is not turning up and down its brightness on the sort of timescale that you're seeing it twinkling. That twinkling is our atmosphere. And what's happening when the star is twinkling is that the light from the star going through the atmosphere hits patches of hot and cold air as it comes through our atmosphere to your eye. And because the speed of light is slightly different in air that's hotter and colder, and that's because hotter air is less dense than colder air, so the light will go faster through the less dense air and slower through the more dense air. And every time the speed of light changes a bit, it has the effect of causing the light to bend a bit. You end up with a twinkle pattern. Now, in the very far distance, a car approaching you, its light has got to pass through a lot of air just above the road surface between it and you. So there's a chance that the same sort of phenomenon could be happening. And if you've got a road that's been baked in the sun during the day, the road surface is going to be heating up the air above the road surface, and it's going to produce patches of hot air, some of which will probably be more pronounced in some areas than others, perhaps because an area of road has been more fiercely illuminated, the adjacent bit might have been in the shade. So there will be areas of air which are of more or greater or lesser density. So I suggest that the reason you see that twinkling pattern is because the air, the light coming to you is passing through these patches of more or less dense air, accelerating or decelerating accordingly and bending accordingly. And that's going to have the effect of making the light appear to twinkle a bit in the distance.
Thanks, Chris. Russell, good morning.
Good morning. How are you?
Good, thank you, sir.
Good. A question on icebergs is: do icebergs contain salt? Because in my learning, that salt melts ice. So if they do contain, why don't they melt? And why don't they melt in the ocean that contains salt?
Hello, Russell. The answer is that icebergs are made of fresh water, because when the water freezes, although the sea is salty, if you make salty water sufficiently cold, it can still freeze. But what happens is that the water molecules fit nicely together, but the shape of the salt particles is wrong and the charge is wrong to fit into this nice crystal of ice that's forming. So you end up with freshwater ice, and the salt is left out of the equation. And in fact, people are talking about, and I've seen various papers put forward as sort of an assessment of whether or not this would be feasible, of going to the Antarctic, grabbing icebergs and towing them to the Middle East, and then using them as a source of fresh water. Because at the moment, countries in the Middle East are spending so much money on desalinating seawater, and then they're creating an environmental catastrophe. There's a paper out this week looking at when you desalinate water, you get very, very concentrated brine. If you just dump that back in the ocean, it kills an enormous patch of ocean because the sea is too salty in that space. So people are talking about dragging these icebergs and using them as a source of water. And in fact, it ends up being more cost effective than just desalinating water. And I think the journey time for towing an iceberg in the paper I saw was about a year to get it from Antarctica to Dubai or thereabouts. And the iceberg would be sufficiently or significantly smaller by the time it arrived, but it would still be viable as a business proposition and a source of fresh water. So the iceberg does melt. It doesn't contain any ice. It does contain fresh water, and it's because you make the sea sufficiently cold that you can still make salt water freeze. Salt doesn't stop water freezing, it just lowers the freezing point. So you have to make it that bit colder to initiate the freezing process. That's why we put salt on the road, for example.
Brilliant stuff. Thank you so much, Chris. Wonderful having you on the show as always. We'll do it again next Friday.
Thanks, Eusebius. Thanks, everyone. See you next time. Bye-bye.